Hi, for this lesson we're going to be finishing off theme 0. So I thought we'd start with this artist's impression of Opportunity Rover, this remarkable geological investigation tool that explored the surface of Mars for an incredible period of time. There were some remarkable discoveries made by it that have set in motion different rover missions to Mars, one of which is travelling there as I record this in 2021. Anyway, we've got a few things we need to finish off, so let's go. This is the area on Mars that Opportunity Rover was investigating. Now, normally we would try and plot out the route of Opportunity, but I realise that not everyone's going to have angle measurers at home, so we're not going to worry about that particular activity. What we are going to think about, though, briefly, is how fast Opportunity Rover was able to travel across this period of time. Now, Opportunity moved about 45.2 kilometres over its time on Mars. The whole mission, from landing to its shutdown, lasted for 5,352 sols. Now, a sol is a Martian day. It's how long Mars takes to rotate, and it's fairly similar to an Earth day in that it's 24.67 hours. So it's a little bit longer than it takes Earth to rotate. What I'd like you to do, though, is I'd like you to work out what the average speed of Opportunity was across the whole of that time in centimetres per hour. So you need to think about converting the distance into centimetres and the time into hours. Once you've done that, you can do the sum. As with any geological calculation, do your conversions first. Before you do any other calculations, convert all the figures into the units that you want to finish with. That'll make life a lot easier. Once you've done that, watch the video on Opportunity Becoming a Teenager. Okay, so press pause now and have a go at working that calculation out. See what you can come up with. Okay then, let's see what you've come up with. So this is the area we're looking at. Let me superimpose Opportunity's route. This is its travels. You can see the end of each year is marked, or its position, should I say, at the end of each year is marked on the route it took. You can see from the spacing of these years that even though we worked out the average speed for Opportunity, it clearly wasn't moving at a constant speed. Just to give you some idea of the scale, this map shows Washington DC superimposed on it. If we're looking for something a bit closer to home, the area of Endeavour crater, the big crater on this map, is about the same as Cardiff and the Vale of Glamorgan put together, if that gives you some idea of how big a space we're looking at there. Okay. So Opportunity's tracks here across the surface of Mars, you can even see the mini dunes that it was driving across. We have a distance in total of 45.2 kilometres. That's the same as 4,520,000 centimetres. 5,352 sols is the equivalent of 132,034 hours. So if we divide the distance by the time, what we end up with is an average speed of 34.2 centimetres per hour. It seems very slow, but as an average across perhaps the most remarkable number of all, the fact that it was doing this for 15 years on the surface of Mars, I think is fairly incredible. And certainly the information we got back from it was remarkable. Let's have a look at some of that by looking through the homework task that you did. There are a few images here from a couple of the different rovers that NASA has sent to Mars. This is from the first rover, Spirit. And Spirit here churned up a little bit the soil that it was travelling on. You can see the tracks there, and reveal that white substance. That white substance is silica, and it's the same type of silica we see being deposited around hot springs. So, for example, if you go to the Giza Basin in Iceland, you walk around the hot springs on these layers of silica that are laid down when the hot water flows away from the erupting geyser and starts to deposit some of the silica that's dissolved in the hot water. So the fact that Spirit found this shows not only that there was water in the Martian environment, but there was also heat from its volcanoes. We see other evidence of the volcanic activity from another location close by. If you look at the rock there that was is highlighted with the arrow, that rock is a volcanic bomb. So it's a lump of rock that's been thrown out of a volcano. And we can see when that rock has landed in layers of soft, wet sediment that it's made an impact. It's made like a little crater. So again, we have evidence of water to create this soft, wet sediment. Also, notice the layers in that sediment, which are typical of water-laying sediments, and also volcanic activity. If you have a look at a couple of opportunities images, this doesn't look like much. This white line on the sort of a red background. This line, though, is what we call a hydrothermal vein. This is where a crack in the rock has had hot water being forced through it. Now, hot water very often will dissolve minerals into it. When that hot water cools down as it's passing through these cracks in the rock, it leaves some of the dissolved minerals behind, and they eventually fill up to create these vein structures. Now, we see the same feature here on Earth. Very often they can have valuable and important minerals in them. More about that in theme 3. But the fact that we see these hydrothermal veins in a different part of Mars shows again we've got water and volcanic activity together. Now, so far, so good. But part of these rovers' missions is to look for the potential for life. This location, photographed and explored by Opportunity, really doesn't look like much. A few broken bits of rock, nothing particularly exciting. Except for geologists, the rocks that are found here include clay minerals. Now, clay is a mineral that is formed by weathering of igneous rocks in water. So for this clay to have formed, there must have been liquid water at the surface, breaking down these igneous rocks in what's going to be quite calm conditions, quite sort of gentle environment, not perhaps like the harsh hot springs that we've seen other evidence for. It's this type of environment that could potentially support microbial life. Now, the rover that's going to Mars at the moment, called Perseverance, its mission is to try and find evidence of this. What Opportunity found was the potential to find that evidence. Okay, we need to finish now with what's in a word. You've got these 7 terms that you have had a go at defining all the way through this theme. So what I'd like you to do now, as geological experts, is to make sure you've completed what's in a word for theme 0. All of these now are terms that we've used as we've been working our way through this theme. So, as we watch a sunset image taken by Opportunity, theme 0 has shown us some of the wider things that we can try and work out within geology. How we can apply our understanding of geological change, not only to our own planet, but to other planets. What we need to do next is we need to explore these ideas in a bit more detail. We need to get stuck into some of the important ideas that underpin the whole of geology. But that's for another theme and another lesson. I'll see you then.